So let's solve some problems with inequalities. Here's an example. Ali's car consumes petrol at an average rate of 8 liters daily. So this is the cost is daily. Okay. And Ali begins his journey. Before Ali begins his journey, he tops up the petrol in his car up to 100 liters. So this is 100 liters. Given that there must be at least 15 liters of petrol in the tank at all times, form an inequality and solve it to find the maximum number of days he can travel before he has to top up the petrol in his car. Now, please note he's going to start out with 100 liters. So he's going to start out with 100 liters, and let's say the number of days is X. Okay, so now every day he's going to spend 8 liters. So in X days he's going to spend 8x liters of petrol, and we know that the minimum amount has to be at least 15. So this must be greater than or equal to 15. Now this is very easy to solve. I can do it formally. So what we can do first is that what I'm going to do is I'm going to add 8x minus 15 to both sides of the equation. If I add 8x minus 15 to both sides of the equation, I'm going to get 100 minus 15 is greater than equal to 8x, which means I can divide by 8. So I'm going to divide both sides by 8. I'm going to get x is less than equal to, please note, 100 minus 15 is really 85. So this is just going to be 85 divided by 8, which is going to be 85 divided by 8 is just 10 whole 5 over 8. Since x has to be a whole number, which means x must be less than or equal to 10. So the answer is that x is less than or equal to 10, since we need x to be a whole number. Okay, and now the way that inequalities are actually solved is you don't actually think about this formally. So this is kind of awkward to think about adding 8x minus 15 to both sides of the equation. What you really think about is that just as in an equality, when you move something across an equality while adding or subtracting, you change the sign. So 15 goes, so this was plus 15. So when plus 15 went to the left, it became a minus 15. And this was a minus 8x, so when it went over here, it became, across the inequality, it changed the sign. So again, when you move a number across an inequality, which is really adding or subtracting, okay, then you flip the sign. If you're multiplying or dividing, you don't flip the sign. So please be careful about it. Or if you want to do it formally, then you can do it this way, which is adding 8x minus 15 is absolutely the correct way of thinking about it. But it's a bit faster to just change signs and move things around, makes calculations a bit faster. Okay, so now let's do the next problem. So the next problem is Wasim has 12 pieces of $10 notes and $5 notes. So the total number of pieces he has is 12. It includes $10 notes and $5 notes. If the total value of all the notes is less than or equal to 95. So I have to say this is less than or equal to 95. So the total value is less than or equal to 95. What is the maximum number of $10 notes he has? So let's say we say that the number of $10 notes is equal to X. Okay. So now what's the amount of money that he has? Well, it's going to be 10X because he has 10X $10 notes. And since he had a total of 12 total notes, so the number of $5 notes must be equal to 12 minus X, right? Because the total notes were 12. So I can say 10X plus 5 into 12 minus X must be less than or equal to 95, because this is the total amount of money he has, 8x plus 5 into 12x. So now we can very easily solve it. So this is going to be 8x plus 60 minus 5x is less than equal to 95. So I can say 5x because you can see 10x minus 5x is equal to 5x, and this is less than equal to, now please note, I'm just going to flip a sign, plus 60, once it goes to the left hand side, will become a minus 60. So this will be just 95 minus 60, right? So this is the negative sign, the flip in sign, the plus flip to a minus, and 95 minus 60 is 35. So that means 5x is less than equal to 35, 35, which implies that x is less than equal to 7 because I've just divided both sides of the equation by 5. Okay, and if you don't like flipping signs, then you can see another thing, which is you can subtract 60 from both sides of the equation, and the plus 60 will get cancelled, and the 95 minus 60 will stay here, and you'll get 35. In either case, the answer is x is less than or equal to 95. Now, if, as in the book, I changed the problem from the book, if it actually says not less than or equal to, but if it is just less than 95 and not less than or equal to, then this will become less than, 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 and this will become less than, and the answer will be x is less than 7, which means the maximum x can be is equal to 6 because x is a whole number. If you solve this problem in which this is less than or equal to 95, then the answer is x is less than or equal to 7, and the highest answer is 7 and not 6. So it depends on what you're trying to solve. I solved a slightly different problem from the book, but I just want you to know that in the book, it's less than 95, so the answer should be equal to 6 because x is less than 7, which is 6. Okay.